Good morning students and welcome to our YouTube channel Gnan Manjari Modern School. So in previous video was not uploaded. Why? Because there was a holiday. Due to holiday on the Monday we haven't uploaded the video. Okay students, but now in this video we will see we are going on the chapter number 11, that is pressure. So first of all we will start from first. I think you, due to holidays, you have just forgot about the old thing. So first of all we have seen was pressure. What is pressure? There was a definition of pressure. What was that? Can anybody tell me, students? I can't listen here, but you can also speak there. Okay students, if there is right then it's good, then if there is wrong then you should learn that. What is the definition of pressure? Pressure is defined as force per unit area. Okay students, the pressure is defined as force per unit area. You have to by heart it that pressure. What is pressure? Pressure is force per unit area. There is a definition of pressure, that is P is equal to F upon A. Here F is force and A is the area. Okay students, so in very first video of this chapter we have seen the two case. Okay students, let me tell that two case. So students, we have seen the two case in this. The first case was, there was a drawing here in the page number 132. There was an, see here, figure 11.1. In that there was a one leg. My drawing is not perfect, but just I am trying to draw properly. Okay students, so this was the case number 1 and here is the case number 2. Here is the case number 2. In that so these are the two case, the case number 1 and the case number 2. So in this what we have seen, first of all pressure is equal to force per unit area. In this case the force is same, force is same. Force is same. Okay students, so now the differ is only in the area. See here, you can see it is small and it is big. So as it is small area, if we put the value in the formula P is equal to F upon A, then what will happen? We can see that here the force is same. There will be no change in the force. In the both case force is same, but area, here the area is small. The area is small. If the area means, if the denominator is small, then we get the answer is high. So we will get the pressure high. Okay students, and in the another case we can see that here if we put P is equal to F upon A, then what will happen? See here, you can see that students, Here the area is large. If the area is large, means the area is big. So, area is big means the denominator is big. So, the value we get is low. So, here it will not hurt as much as it. Okay students, it will hurt more. It will not hurt more. So, this is pressure, that how the pressure is increased and how the pressure is decreased. Then after we have seen some of the activities, and then we have seen the some of the numericals in the videos. Okay students, here we have then see the activity here in the page number 133, and then we have seen some of the numericals. I have also given this in the homework, and then we have seen in pressure in fluids. So, there was an activity of balloon that it will blast. Okay students, and then we have seen the atmospheric pressure activity, that only we should put a disc on the glass and then it will remain same. That activity we have seen. And next activity, here there was activity the presence of atmospheric pressure, the another activity we have seen, and here we have seen the atmospheric pressure definition. What is atmospheric pressure? Atmospheric pressure is defined as the pressure exerted on an object by the weight of the air above it. Atmospheric pressure, please repeat with me. Atmospheric pressure is defined as the pressure exerted on an body by the weight of the air above it. Okay students, this is the definition of the atmospheric pressure. And then we haven't seen the let's answer, that was in the page number 137. Let us solve that first of all. In that the first one is fill in the blanks. Let us answer page number 137. Okay students, so in that first, an object immersed in a fluid experience pressure in dash direction. Means an object immersed in a fluid experience pressure in, if an object is there and if we put that in the fluid, and which for pressure is act on it in from which direction, then there will be from fill in the blanks A, F, B. First, the answer will be all direction, from all the direction. Next, atmospheric pressure acts in dash direction. Atmospheric pressure acts in all the direction. Second, also there will be all. Third one, dash pressure is the pressure exerted on an body by the weight of the air above it. We have just seen before only 30 or 40 seconds that atmospheric pressure is the pressure exerted on an object by the weight of the air above it. Atmospheric. Atmospheric. Okay students, next is true and false. Next is true false. So in that, true false, the first one is pressure is independent of the area over which the force acts. It is false. First one is false. Second, A blunt needle exerts a small pressure as compared to a sharp needle for the same applied force. This is also false. Third one, a great force produces a lesser pressure. A great force produces lesser pressure. What do you think, students? It is false. A atmospheric pressure decreases as the altitude of a place increases. Yes, that is right. So it will come true. Okay, students. So please write down this, students. Let us answer on the page number 137. Next we have seen was pressure in liquid. So in that we have seen one activity, that first of all we have to fill the balloon with water and then put into a bucket full of water. Okay, students, in that the balloon will go the downside, but then the next we have to do was the take out the water from the balloon and then fill air in it and then put it in the bucket full of water, then it will remain on the surface of water, and as you will try to push that balloon in the water, the force, some of the force come back. That is pressure in liquid that we have seen, students. Then also we have seen that the dam, how the dam is built. Okay, students, and then we have seen a manometer. It is used to measure the pressure. Okay, students, manometer is used to measure pressure. And next, up to this we have seen, next was applications of pressure. Next point was applications of pressure. Applications of pressure. So here are the applications of pressure. See here, I am reading that many useful devices and equipment have been manufactured by applying the concept of pressure and what it depends on. Here are the few examples along with the principle behind the applications. Pressure can be increased by reducing the area over which the force acts. See here, I am writing this, the first application. I think we have studied in the previous video, but then also I am just explaining this. Pressure can be increased by reducing the area over which the force acts. Okay, students, in this what they are telling, let us see that pressure can be increased by the reducing the area over which the force acts. Okay, students, means if we want to increase the pressure, see here I am writing the formula, P is equal to F upon A. So what they are doing is just pressure can be increased pressure, they want to increase the pressure. So how they will increase? By reducing the area over which the force acts. Means they will reduce the area so that the pressure is maximum. In the very first, we have seen that as the area decreases, the pressure value increases. So for the increasing of the pressure, what they do, they just reduce the area so that the pressure value goes increasing and the force remains same. Okay students, we all have seen in the sum of the numericals in the very second or third video. We have seen the numericals. In that, we first of all increase the area and then decrease the area. We can see the value of pressure is different from each other. And next, see here, first of all I am reading that needles, pins and thought, cloth, paper, skin, etc. as they need may be. Knives and blades are given sharp edge so that they can be used to cut things without much efforts. See here, you can see the figures 11.7 and 11.8, in which needle of a string has a sharp point and easily pierce the skin, and knife has a sharp edge and cuts thing without much efforts. So what they do, they decrease the area so the pressure value increases. Okay students, next is pressure can be reduced by increasing area over which. See here, the next point is, if we want to reduce pressure, then what we have to do? Pressure can be reduced by increasing area increasing the area over which the force acts. Okay students, so here is the pressure can be reduced by the increasing the area over which a force is acts. Okay students, how to reduce the pressure? Pressure can be reduced by increasing the area over which the force acts. Let me write here the formula, that is P is equal to F upon A. So what they want to do, they want to reduce the pressure. For that, what they do, they increase the area. They will increase the area so that the pressure value will be decreased. Okay students, first case was pressure can be increased by reducing the area over which the force acts, and second case means in the first case they want to increase the area, increase the pressure. So what they do, they reduce the area, and in this next case they want to they want to reduce the pressure. So what they do, increase the area. They will increase the area so that the pressure value will be decreased. Okay students, next, before that let me read that the large area of skins seen in the figure number 11.9. See here, in the next page there is a figure. See here, you can see that the large areas of skin reduces the pressure a person exerts on the snow and thereby keep the feet from sinking in the snow. Okay students, see here, have you noticed that the tires of different vehicles have different weight? Bicycle tires are very slim, whereas big buses and trucks have very wide tires, sometimes even 2 or 4 tires together instead of 1, 2. Understand this, we have to remember that the pressure is force per unit area. Big vehicles like buses and trucks have a bigger weight, that is, they exert a great force on the road as compared to the lightweight bicycle. To compensate for a large force, the wheels of buses and trucks are made wide to increase the surface area so that the pressure exerted on the road is reduced. See here, in the snow, we know that skills are very big, so that the area is big, means the force is the pressure is less. Otherwise, if we don't wear skills, then our leg goes inside the snow, so that the area increasing, means the skills are very big, so that our legs do not go into the sea. And the next case was of bus and trucks. In that, what they do, the trucks and buses are very heavy weight, so that if their weight is heavy, then if there is only not more than more tires, then if the tires are having less weight and height, then the pressure on the road is high. So what they do, they increase the tires and the width of the tire, so that the pressure value decreases on the road, so that the road do not get do not damaged. Okay students, here applications of atmospheric pressure. What here we will see now, applications of the atmospheric pressure. In that, let us see that now we will see the applications of atmospheric pressure. Applications of atmospheric pressure. Applications of atmospheric pressure. So first of all, we have seen that what is atmospheric pressure. In that, what is atmospheric pressure? Let me read the definition. The pressure exerted on an object by the weight of the air above it is called the atmospheric pressure. So when we use a straw to suck and drink a liquid, that is seen in the figure number 11.11, we immerse one end of the straw in the liquid and sucked at the other end. In the beginning, air is sucked out of the straw, creating a low pressure inside the straw. Outside the straw, we have atmospheric pressure pressing down on the surface of the liquid. When a low pressure is created inside straw, atmospheric pressure forces the liquid to rise into the straw. Okay students, that we have seen that. So the applications of atmospheric pressure, in that we have seen, I have read just the example that there is a straw, we are just drinking cold drink or anything else. In that, what it do, it just create the pressure, so that low pressure, that the liquid travels from the straw and goes into our mouth. Okay students, let me read again this. When we use a straw to suck and drink a liquid, we immerse one end of the straw in the liquid and suck at the other end. In the beginning, air is sucked out of the straw, create a low pressure inside the straw. Outside the straw, we have atmospheric pressure pressing down on the surface of the liquid. When the low pressure is created inside straw, atmospheric pressure forces the liquid to rise into the straw. Okay students, inside a vacuum cleaner. How the vacuum cleaner works? See here, there is a fan that makes the pressure inside lower than the atmospheric pressure outside. The pressure difference makes the air outside along with the particles of the dust and dirt rust rush into the vacuum cleaner. Okay students, in vacuum cleaner also this low pressure is created and the all the dust and the dirt comes into the vacuum cleaner. So this is the applications of atmospheric pressure. What was the first application? The first application was how the pressure acts on the atmospheric pressure acts on the straw or the what we are drinking with the straw. What happens? First of all, air creates a low pressure and then the liquid comes upside on the straw and it creates low pressure, so that the liquid comes upper side. And in the next application, that was vacuum cleaner. How is the vacuum cleaner work? There is a fan which creates low pressure than the atmospheric pressure, so that the dust, dirt and the rust comes inside the vacuum cleaner. Okay students, so these were the applications of the atmospheric pressure. Now what we will do, see here, now the chapter is over. If there is any doubt in this chapter, you can inform me in the group or you can also message me in personal, because sometimes the groups are not open, so that you can't post a message in the group. Okay students, see here, if there is any doubt you can tell me, or else we are just I am giving the homework to you. In the homework, what you have to do? Please note down your homework students. Here your homework. In that you have to just find out the answers of, here there is an exercise in the back side. You have to just find out the answers of question, choose the correct answer, fill in the blanks, match the following and answer the following question. Okay students, what you have to do? Find out the answers of exercise. Find out the answers of MCQ, fill in the blank, fill in the blanks, match the following, match the following. Okay students, you just have to find out the answers and also the answer the following question. Answer the following questions. You just have to write the answer the following question in your fair book. You don't have to write this fill in the blanks MCQ and match the following in your fair book. Okay students, you have just to write the answers in your textbooks of MCQ, fill in the blanks and match the following, and you have to write in your fair book answer the following question by the use of textbook. Okay students, find out the answer and write down in your fair book. If any of the answer you don't get, then you can tell me, so that I will find out the answer and tell you. Okay students, up till then stay safe, stay home. Okay, bye students. And also I will give the answers of MCQ, fill in the blanks and match the following in the next video. Okay students, up till then stay safe, stay home. Okay, bye students.